Here, the values of E and D are always fixed. This is a pseudocode that is used for the key generation in Rabin Cryptosystem. Bob calculates the N equals P into Q, which takes 161 as the value. This is how a plain text is carried to the ciphertext. Hello students, welcome to the next session of Network Security. I am Dr. Soumyashri from Department of Computer Science, Vidhyaashram, 1st grade college. Let's start this session. This session is all about knowing another crypto system that is used in the modern asymmetric key cryptography. Okay, that is the Rabin Cryptosystem. Let's know what is this Rabin Cryptosystem and how it is differentiated from the RSA cryptosystem. Okay, the Rabin cryptosystem can be thought of as an RSA cryptosystem, improvisation of the RSA cryptosystem in which the value of the E and D are fixed. Okay, so it will be E and D will be fixed and it uses quadratic congruence. The RSA cryptosystem uses the exponential congruence, whereas the Rabin cryptosystem uses the quadratic congruence. Okay, here the values of E and D are always fixed and it is not going to be changed. The encryption expression in the Rabin cryptosystem is ciphertext equals plain square of plain text by mod n. It is rather simpler than the RSA cryptosystem, and the decryption is P equals C of half, C to the power of 1 by 2 mod n. The value will be half reduced and is applied for the mod n, whereas in encryption the plain text it will be squared with the modulus operation of n. Here we have a diagrammatic representation of how does the Rabin cryptosystem can be implemented in the security model. Okay, here we have the key generation process, selects the P and Q values and it is multiplied to get the n. Okay, so this n will be provided as a public key. Okay, here we have PQ acting as the private. The multiplication of PQ will act as the public key. Okay, so public key will be given to the receiver. So receiver is going to use this n in the encryption expression. C equals P to the power of 2 mod n. So it generates the encryption group that Z to the base n, that is total number of characters in the message, with a congruence, that is the exponentiation congruence it uses, and we get the ciphertext. To calculate the ciphertext or to get the plain text, the intruder has to execute this square root of C mod n to get the plain text, which is not feasible one for the attacker. So it is also a stronger crypto system that we can use. Now the quadratic residues have been used in case of the decryption. The private key is used to decrypt the message. Decrypt will have same set of values as that in the encryption. The decryption method is going to use the set of the values Zn into the congruence values and apply the quadratic congruence to the expression and calculates the plain text. Okay, so this is the general implementation of the Rabin cryptosystem. Okay, this is a pseudocode that is used for the key generation in Rabin cryptosystem. So Rabin key generation chooses the two large primes P and Q in the form 4k plus 3, where P is not equal to Q. So P into Q, the quadratic equation is used for getting the total number of characters. Then it is working as a public key. Then we use the public key, private key along with the characters in the public key, that is Q comma N. Okay, we return both the public key and private key to the main function, where private key is kept by the algorithm with the receiver itself, and the public key is announced publicly and will reach the sender of the message. Okay, then we have the function of encryption, how it is going to encrypt the text. So we have the encryption pseudocode, we have the total number of characters and the plain text. We are going to get the cipher text by applying this expression, that is p to the power of 2 mod n. This operation is applied, which returns the cipher text to the main function in the program. Okay, so this is the pseudocode for encryption. When you look at the decryption in a Rabin cryptosystem, decryption is quite a long process which uses the quadratic congruence to perform the decryption process. Okay, here we have the prime values, private keys, P and Q private keys, and C is the cipher text which acts as the parameter to the decryption function. Here we use each of the character like A1, A2, B1, B2. So these are the set of text included as a block. If it is greater than n, it will be divided into n. Plain text is divided into blocks. For each block, the public key is applied or the private key is applied now. Since it is a decryption, private key is applied. C P plus 1, that is prime value plus 1 divided by 4 mod P. For A1 and A2, P will be, so first set of primes will be applied. A2 will have same, again mod P generates the second character. Then we have the B1, C of Q plus 1. Now another prime is taken by 4 mod Q. Then we have B2 which takes plus or minus values. Okay, so it takes C of Q plus 1 minus 4 mod Q. So A1 takes plus, A2 takes minus, B1 will be positive, B2 will be negative values. So we get set of plain text. The algorithm for the Chinese remainder algorithm is used 4 times. So Chinese algorithm, what is Chinese algorithm? We'll discuss later. Okay, so we use the Chinese algorithm theorem for applying the values. Then we use the Chinese remainder for these 4 characters which returns the character P0, that is P1, P2, P3 and P4. We consider 4 blocks of plain text. So these blocks will be obtained by applying the Chinese remainder theorem. Okay, with A1, A2, B1 and B2 along with the prime values. Okay, this is a decryption algorithm. Here, discuss some of the basic examples to know the implementation of the crypto system. We have the trivial example. Bob selects the plain text value as 23 and Q as 7, set of 23 and 7. Note that both are congruent to 3 mod 4. Okay, they are equivalent to congruence to 3 and 4. Okay, so Bob calculates the n equals P into Q, which takes 161 as the value. Now Bob announces n publicly, that is 161. He keeps P and Q private. You can't calculate P and Q if you have n, isn't it? It is difficult. So n is made public and P and Q are kept as the private key. Okay. Now the sender, Alice acting as a sender, wants to send the plain text P having the values 24. Note that 161 and 24 are relatively prime. They are prime to each other. That is 24 is in z to the base 161. It is the prime, relative prime of the 161, that is 24. She calculates C equals 24 to the power of 2. That is P to the power of 2 will be there. 24 to the power of 2, that is equal to 93 mod 161. So we have the 93 mod 161 and sends the ciphertext 93 to the Bob. This is the encryption process. This is where encryption happens. What happens while decryption is reverse of that, isn't it? So another example, if you assume that we have another person, John, wants to send a message to Bob. He is going to send a message to Bob. John can use the same public key announced by the Bob. He can use the same public key which is announced by the Bob, which is 161, isn't it? So he uses the same value, 13. John's plain text is 63. So John calculates the ciphertext like this. C equals 63 to the power of 13. So it is E and D. 28 mod 77 we get. So ciphertext we get is the 28. Okay. Now Bob receives the ciphertext 28 and uses his private key 37. So 37 is the private key he has used to decipher the ciphertext. So he uses ciphertext 28 to the power of 37, not the power to the congruence of 37, which gives the value 63 mod 77, where the plain text we generate is the 63. This is how a plain text is carried to the ciphertext. A ciphertext is carried to the plain text in a Rabin cryptosystem. Okay. Another example we have is the decryption method. How does the decryption happens? So Bob receives the value 93 and calculates 4 values. How does it? He is going to do that. A1 equals plus of 93 to the power of 23 plus 1 by 4. That is 93 to the power of 6 mod 23 will give 1 mod 23. Now we have 93 minus values give negative congruence, that is 22 mod 23. This gives 1, this gives 22. 93 to the power of 7 plus 1 by 4. Now we have mod 7, it is 4. Now we have 93, 7 plus 1, that is 93 square mod 7. It is 3 mod 7. We get the 3. Okay. So this is 4 values, A1, A2, B1, B2, positive and negative values. Bob takes these 4 possible answers as a set, A1, B1 and A1, B2 and A2, B1 and A2, B2 and uses the Chinese remainder theorem. Again uses the Chinese remainder theorem to find 4 possible plain texts, that is 116, 24, 137 and 45. He gets 4 texts. Note that only the second answer is Alice plain text. So this is the plain text that Alice has sent. So he gets 4 values. He has to check which is the plain text that is sent by the sender or the Alice. Okay. Now let's move on to the another type of crypto system, that is the L-gamma crypto system. So this L-gamma crypto system how it differs, what is the difference between LGAML, the RSA and the Rabin cryptosystem. So it is based on the discrete logarithmic problem. About these congruences, logarithms, I'll tell you in the next sessions. So LGAML is based on the discrete logarithmic problem. Okay, here we have the procedure of how does the key generation, encryption and decryption can be implemented in the LGAML crypto system. So here we have the key generation procedure in this crypto system, where the LGAML crypto system mainly deals with the large set of primes. Okay, when there is large set of primes, we use E1 as the selective root. Okay, so you can select D now and you can calculate E2 equals E base 2 equals E1, that is the first primitive root, to the power of D mod P can use, which takes as the form of the public key. So we use E1, E2 and P as the public key in case of LGAML crypto system. So it is applied to the plain text. We use C1 equals E1 to the power of R mod P. C1 equals, again we use the expression E2 to the power of R into P mod P, which takes the encryption. Okay. Now we have the ciphertext C1 and C2. Two ciphertext set will be generated, C1 and C2. When it comes to the receiver uses the private key D. Okay. So P plain text can be generated by using C2 into C1 to the power of D minus 1 mod P. Okay. So using this expression, decryption can be done and can generate the plain text. Okay. The pseudocode for key generation is given here, which generates the LGAML key generation pseudocode. So we select large prime numbers P and select the D to be a member of the group G. G, here we have set of Z to the base P such that D is between the values 1 and P minus 2, that is large set of primes. So select E1 to be the primitive root in this group of G. E2 tends to be E1 to the power of D mod P. We calculate this and then use the public key as E1, E2, P. Then D is used as the private key and is kept with the receiver, and E1, E2, P will be publicly announced and is available to everyone, to the attacker or to the sender in the network. It is available to all the senders and returns the public key and the private key to the main function. So the receiver keeps the private key and public key will be announced publicly and will be receivable by all the senders as well as the attackers. Okay. So this is the key generation procedure. We have the power of integers of module 19. How we can use the power of integers using this table. Okay. So we have the powers of the integer like 2 to the power of 4, 8, 16 like this. 3 to the power of 2, 3 to the power of 3 like this. We can use and we can make the modulus of the values and is kept here. Modulo 19 is done. Power of integers modulo 19 will give these values. Okay. So this is the set of integers. Power of integers modulo 19. We can use these for calculating the public key. Okay. Then we have the algorithm for the L-gamma encryption. How do you encrypt this? So we get 3 sets, E1, E2, large set of primes and P as the plain text. So you can select a random integer R in the group of G, that is set of characters in the respective language in which message has sent. C1 equals E1 to the power of R mod P. You can calculate this. Then C2 equals P into E base 2 to the power of R mod P. Then you can return 2 sets of plain texts C1 and C2 so that it is used for confusing the adversaries or the attacks to think which is the ciphertext which is going to be used for getting the plain text. So we get 2 sets of ciphertext C1 and C2. Now we have the process of the decryption. How you are going to decrypt that? We get 4 values D and large set of primes and 2 blocks of ciphertext C1 and C2. We use both the blocks here. C2, C1 to the power of D, inverse of C1 to the power of D is multiplied with C2 and its modulus operation is done with the P to get the plain text. So in decryption algorithm, plain text will be returned to the main function and the plain text will be received by the receiver system. This is how you can perform the encryption and decryption in L-gamma crypto system. Let's check with the last type of crypto system, that is the elliptic curve crypto systems. Although RSA and L-gamma are secure form of asymmetric key crypto system, the security comes with a price. What is that price? They have comparatively large set of keys. Okay, so researchers have looked for the alternatives. What type of alternative give the same level of security with smaller key sizes so that security will be same but the key values will be less. So one of the crypto system that you can use is the elliptic curve crypto system. So this is based on the elliptic curves. We use the general equation for an elliptic curve, which is the general equation we use is y2 plus b1 into xy plus b2y. We use the curve elliptic curve expressions for this equals x3 plus a1 into x2 plus a2 into x plus a3. So general equation for elliptic curve will be used here. Okay. So these elliptic curves over real numbers use special class of elliptic curves. So those elliptic curves has the expression y2 equals x3 plus ax plus b. We use this elliptic curves to calculate the real numbers. Okay. So expression that we can use is y2 equals x3 plus ax plus b. So in the next session, I'm going to explain you how we can use these expressions to calculate the elliptic curve for the real numbers. Elliptic curves is like this, isn't it? So if you remember the elliptic curve diagram, so this will be like elliptic curve. You have to get the set of real numbers with the help of these elliptic curves, which helps in getting the ciphertext set and the plain text set. How they are going to generate these plain text and ciphertext will be in the next session. I'm going to discuss about these things. All right. Thank you.